Okay, let's discuss a question from fluid mechanics. Here, what is asked is the force F required to support a liquid of density D and the vessel on the top is okay. Now, the force F that is acting on this piston. So, if you draw the free body diagram of this piston, now nothing is mentioned about the uh, weight of the piston, so we will assume that it's a massless piston. So now if you draw the free body diagram of this piston, FPD of the piston only, remember it's only the piston, you have vertical force F, which is what we are supposed to find, and the force that is acting here, I mean that is the fluid pressure. Okay, that is the force that is coming is the fluid pressure. Now remember that it's a static mass of fluid, and so you don't have anything, I mean you don't have any acceleration in the horizontal direction, so the pressure will remain same throughout and it's a uniform pressure, right? Okay, it's a uniform pressure P. Okay, and so the total force here will be P into the area of cross section, which is A. So F is the pressure that is acting at this point into A, and the pressure that is acting at this point can be straight vertically found out by taking, I mean here you have 0, I mean basically you don't have anything, you have the atmospheric pressure. I think in order to make it more interesting, on the bottom when you have force F, remember that on the bottom you have something called atmospheric pressure, so that force will be atmospheric pressure into area of cross section. Remember at the bottom you have a force F which is externally applied as well as some atmospheric pressure into A, whereas at here the pressure is P. Okay, so this equation will be F plus P atmospheric into A plus F is equal to P into A, where P is the absolute pressure acting at point number 2. Remember this is point number 2 and this is point number 1. Now in a static mass of a fluid, pressure varies vertically downwards, and that is P2 is equal to P1 plus rho GH. Okay, and what is P2? P2 is P and P1 is P atmosphere plus rho G. H is the capital H, right? H is the capital H. Okay, so if I substitute this the second equation in the first, what I get is F is equal to P minus P atmosphere into A, and P minus P atmosphere from this equation is rho G H into A. So rho G H A is the answer. The answer for this is rho G H, and rho is basically density. Density here it is given as D, so we have assumed it's rho throughout. So let's now keep it as D G H A. Okay. Normally I take, when I solve the problem I start with rho, but then you have to look at the problem. It's given as D. So D G H A is the answer. The answer to this is B. Many people would be interesting to know why this doesn't matter. I mean why we have not considered this thing. Now what you have to see, what we are interested here. We have drawn the free body diagram of the piston. At the bottom you have P atmosphere into A, that's okay, and at the on the surface of the piston at the top you have P which is uniform. So it is sufficient enough if I calculate this P, which is nothing but P2, and how I have calculated P2 is that because the static mass of fluid, so if I take any point here at the toppest point, from that point I will just vertically vary the pressure varies vertically by rho G H. It increases vertically downwards by rho G H in a stationary mass of fluid. Okay, irrespective of the size of the vessel. This is a very important fact. From this, because remember that how this was derived. This was derived by taking a very small vertical column. So if I assume a very small vertical column here and then do the force balance, I end up getting this equation. So it doesn't matter, the size of the vessel doesn't matter. Okay, so this is a simplest way of doing this problem. many people would be interested is why can't this force will be nothing but the weight of the fluid, and weight of the fluid again you can just find out by just summing up, by just area of this into the perpendicular width to g. But the force that is acting on the piston is not the weight of the fluid. Apart from the weight, is not the weight of the fluid only. The force that is, I'm telling you the other way of calculating, the force that is acting on this piston is weight of the fluid plus also there is some force here, so that also, that force plus weight of the fluid, that together is, that is acting here. So these forces also you have to consider. Okay, so you cannot directly say that this force F is just equal to the weight of the fluid, because then you will get a very different answer. But if you do in this way, weight of the fluid plus these Fi's, and how do you find these Fi's? These Fi will be the pressure here, which is rho g small h into this area of cross section. So that will be a bit lengthy way, but what I have told you is a shortest way and the correct way. Okay, so don't get confused by these small h's and these small a. Ultimately what matters is the pressure that is acting on the piston, which we have calculated by applying P2 is equal to P1 plus rho gh. Okay, so this is the first way and the simplest way. The other way, as I told you, the weight of the fluid, you would have directly taken the weight of the fluid had it been a vertical walls throughout, but it's not the vertical walls throughout. So the weight of the fluid plus these Fw's which come at these. Okay, so remember that, but that will be a lengthier way. Okay, so understand the difference of solving in these two ways. You will get the correct answer in both the ways. Okay, but one is lengthier and the method which I have written is the shortest way but the correct way. DGHA. Thank you.